I'm going to talk about the emerging technologies. First of all, I'm going to introduce our group members. The first one is Nur Nafisa binti Muhammad Khushairi. The second one is me, Nur Najah binti Muhammad Nizam. The third one is Nur Farisha Ayuni binti Muhammad Fairuz, and the last one is Nur Kamariah binti Rosman. So first of all, I'm going to talk about introduction. To know about the emerging technology, we're going to define the emerging. Emerging means the newly created or noticed and growing in strength of popularity, while technology means the application of scientific knowledge to the practical aims of human life, or as it is sometimes phrased, to the change and manipulation of the human. For the emerging technologies, it is a term generally used to describe a new technology but also refer to the continuing development of an existing technology. The term commonly refers to technologies that are currently developing or that are expected to be available within the next 5 to 10 years, and is usually reserved for technologies that are creating or are expecting to create significant social or economic effect.
Let's look to the next point, which is relevant electricity and magnetism concept. Electricity and magnetism are closely related. Flowing electrons produce a magnetic field, and spinning magnets cause an electric current to flow. Electromagnetism is the interaction of these two important forces. First is electricity. Electricity deals with the presence and flow of electric charge. Electric charge is a fundamental property of a matter, and there are two types, which is positive and negative. Like charges repel each other and opposite charges attract each other. The movement of electric charge is what we refer to as electric current. It can flow through conductive materials such as metals or through solution as in electrolytes. Let's look at the electricity concept, which is electric charge, electric current, electric field, electric potential and voltage, and also resistance and Ohm's law. Next is magnetism. Magnetism arises from the movement of electric charges. When charged particles such as electrons move, they create a magnetic field. Magnetic field exerted forces on the other moving charges, causing them to experience a force called magnetic force. Materials that can be magnetized, such as ions, have domains where the magnetic field of individuals atoms align to produce a net magnetic field. For magnetism concept, we have magnetic field, magnetic flux and flux density, and lastly is magnetic induction. Lastly is electromagnetism, which is the topic I'm going to explain today. This is the study of interaction between electrically charged particles and magnetic fields. One of the fundamental laws governing electromagnetism is Maxwell's equations, which describes how electric and magnetic field are generated by charges and current and how they interact with each other. There are a few examples of electromagnetism in daily life. For example, like electric motors, where these motors convert electrical energy stored in the vehicle battery into mechanical energy to drive the wheels. Electric motors operate based on the principle of electromagnetism, where the interact between electric currents and magnetic field generates a force that produces motions. Next point is battery charging. Charging an electrical vehicles involves transferring electrical energy from an external power source to vehicle's battery, such as charging at the station. This process relies on electromagnetism, as the charging station generates an alternating current that induces a charging magnetic field. The vehicle's onboard charger then converts the alternating current to direct current to charge the battery. Last point is wireless charging. Wireless charging technology for electric vehicle is an emerging area that utilizes electromagnetic induction. In this process, an alternating current passing through a charging pad creates a changing magnetic field. When the EV is parked over the pad, a coil in the vehicle's charging receiver picks up the changing magnetic field inducing an electric current in the coil, which is then used to charge the battery.
For the exploration of chosen application or technology, first we have artificial intelligence, which is AI. AI involves the development of computer systems capable of performing tasks that typically require human intelligence, such as learning, problem solving, and decision making. Machine learning, a subset of AI, enables systems to learning and improve from experience without being explicitly programmed. AI applications span various fields, includes healthcare, which is diagnosis, personalized medicine, finance, fraud detection, trading algorithm, and transportation, which is autonomous vehicles, and entertainment, which is recommendation system. The second one is biotechnology. Biotechnology involves the use of biological system, organism, or living organism to develop products and applications for various purposes. Genetics engineering allows scientists to manipulate the genetics makeup of organisms, enabling the creation of genetically modified organisms (GMOs) with desired traits. CRIPR Cas9 technology enables precise gene editing by targeting specific DNA sequences and offering potential application in healthcare, which is gene therapy, disease treatment, and agriculture, which is crop improvement and pest resistance. And the last one is biomanufacturing, which is drugs production and biofuel synthesis. For the last one is Internet of Things, which is IoT. IoT refers to the network of interconnected devices embedded with sensors, software, and other technologies, which is to enabling them to collect and exchange data. IoT applications range from smart homes and cities, which is connected appliance, automated lighting system, to industrial automation, predictive maintenance, supply chain optimization, and healthcare, remote patients monitoring, wearable devices.
Next, I'm going to continue with the example of real-world implementation. The first one is big data and analytics. Big data is the term used to describe huge amounts of data that, with the use of powerful computing power, may be converted into insightful findings. Making choices when purchasing is supported by the analysis of supply chain variables, sales data, and information from providers. The next one is autonomous robots. These independent devices are capable of doing tasks smartly, even in the absence of human operators. Autonomous robots are employed in manufacturing to perform functions such as handling materials, construction, and quality check. The next one is simulation and digital twins. Digital twins are digital copies of real-world resources or operations. They let producers forecast maintenance requirements, increase productivity, model, and optimize the process of production. Next, I'm going to explain potential benefits and challenges. And the benefit is greater productivity and process streamlining. Robotic and artificial intelligence or AI technologies can lower labor costs and increase efficiency. And the next one is cost savings. By increasing productivity, lowering mistakes, and allocating resources more effectively using new technology can save costs.
Okay, next for the challenge. First, we have economic disruption and inequality. It disrupts traditional industries and labor markets. It causes job displacement, especially in routine task sectors, and it benefits to those who advance skill or education, while others struggle to adopt. For the second point is security risk. It is a new technologies that can introduce vulnerabilities, creating more entry points for cyber attacks when more devices are connected, and it also can be exploited for malicious purposes such as advanced phishing attacks and automated hacking.
For an emerging technologies future development, for the first point is quantum charging. Quantum computing, electric and magnetic fields are relevant to other quantum technologies such as quantum communication and quantum sensing. Quantum communication systems rely on the manipulation of quantum state using electromagnetic field for secure transmission of information. Quantum sensors which exploit the principle of quantum mechanism to achieve unprecedented levels of sensitivity, often involve the control and measurement of electric and magnetic fields. For the second point is energy storage and conversion. Techniques such as magnetic resonance imaging (MRI) and transcranial magnetic stimulation (TMS) rely on the interaction between magnetic fields and biological tissue. MRI uses powerful magnetic fields and radio waves to create detailed images of internal body structure, while TMS applies rapidly changing magnetic fields to stimulate nerve cells in the brain for therapeutic purposes. For the last point is medical imaging and therapy. Electric and magnetic fields are crucial in the development of advanced energy storage technologies such as supercapacitors and magnetic storage systems. These technologies offer high energy density, fast charging, discharging rates, and long cycles life, making them promising candidates for application ranging from portable electronics to grid-scale energy storage.
Next is the future innovations of the emerging technologies. First, we can have an artificial intelligence or AI. It is enhancing automation, improving decision making, enabling personalized service, advancing medical diagnostic and driving autonomous vehicles. Next is the blockchain. It is increasing security and transparency in financial transactions, supply chain management, voting system, and digital identity verification. And then we have the quantum computing that can solving complex problems in cryptography, optimization, material science, and drug discovery that are currently unsolvable by classical computers. For the fourth one, we can have an Internet of Things or IoT. It can enable smarter cities, homes, and industry through interconnected devices that improve efficiency and data collection. Then we can have the biotechnology. It advancing personalized medicines, gene editing like CRISPR, and agriculture productivity. And the last one is 5G and beyond. It can enhancing connectivity, enabling faster data transfer, and supporting innovation in augmented reality (AR) or virtual reality (VR) and IoT. In conclusion, emerging technology represent a powerful driver of change and innovation across various sectors. Emerging technologies such as artificial intelligence, blockchain, quantum computing, and biotechnology promise us to revolutionize industry by enhancing efficiency, enabling new capabilities, and creating new business models. However, they also pose challenges including ethical consideration, cybersecurity risks, and potential disruption to existing job markets. Therefore, the successful integration of emerging technologies requires careful management, strategic planning, and regulatory frameworks to ensure they benefit society as a whole while mitigating associated risks.